Hello everyone. So this is a late night coding session one. So in this session, we are trying to solve this question in 10 minutes and understanding all the logic and why we are using this one. So like it is a daily challenge for this date 15th, this 15th June, and this question is that I delete the middle node of the linked list. So how we delete the middle node of the linked list? So like topic is medium. Okay. So like you are given. So first of all, you are given a head of this linked list. So we are given with the head of linked list and delete the middle node of this one. So that is middle node that is 7 in this question. Okay, deleting the middle node and return the head of the modified linked list. So that middle node of linked list is like half of this portion. Okay, so just imagine we have like three member on this side, three member on this side. So, okay, and starting from this ny2 from the starting using the zero based indexing, and where this denote the largest integer less than or is equal to x. So n is 1 2 3 4 5 and the middle node will be like middle node are like 0 1 1 2 2 5. So let's see. We have 1 3 4 1 3 4 7 1 2 6. So these are the like head values. So what is like I didn't understand this portion, so I have to see that this one. The middle node is denoted as this one. Okay, so if size is n, okay, I got it. So if size is n, so this size is 6, okay, and the n by 2th node that is 7. Okay, I know from the starting this thing. Okay, where this portion, so this is portion is like seal value. Okay, so seal value is this thing from the starting node and denote sorry, largest integer less than or is equal to x for 1 2 3 4 5 for n is equal to 1 2 3 4 5. The middle node will be for the 1 n is equal to middle node is this thing. For 2, for n is equal to 2, the middle node is like this portion. For this value the middle node is not getting this question. Once again I have to read this question. So like less than is equal to, for n is equal to 1 2 3 4 5, the middle node are 0 1. N is equal to like for n is equal to this thing. For 0 it is 1. Okay, this is 1. Okay, and this is 1. So it's 2. From the above figure represented in the given linked list, the indices of the node are written below, and since n is equal to 3 and node 3 and the node 3 will be the value of 7. So 0 1 2 3. So node 0 is the 7 value, which is marked as a red. We will return the new list after removing that linked list. Okay, delete. Okay, so it is a basic mistake we always do, like all the beginners do at this position. We have to read the question carefully. We have to delete the middle node. So first of all, if we delete this middle node, okay, if we delete this middle node, and what we have to return, and return the head of that modified linked list. So if we remove the middle node, so in that case, first of all, it will be 1 3 4 7 1 2 6. See, if we remove this portion, so the head will be for head for this portion is equal to 1. Okay, 1. And if we remove, like we have now come with this 1 3 4, if we remove the head like this thing 4, so head will be 1. Okay, now head of this modified linked list, head of the modified linked list will be pointing at, so it become 1. So 1 3 1 2 6. So this will be the answer. We simply have to delete the middle node. Okay, this is not like hard question. I was thinking that it is hard question. So in this question, this is middle node. So we have 4. So divided by 2 is 2. So 0 1 2. Okay, we have like two values. So at 1, and this you can see the output is in the vector form. So how we like recall, so how we go at this position. So our like movement or traversal on the linked list we can do from this position, and is equal to, so we have to like just we have to go in this position, go this position. If we reach to the n by 2 position, then we skip that portion and we link to this position and return everything. So my thinking is that mm, if we have this node, if we have 1 2 3 4 and 5, so we are, if we want to delete this portion and we want to return this value, so we are starting from this position, so we will like return this thing 1 and push into the this result index 1, then go to 2 and push that value again. We want to go at 3, but this is our middle index, so we try to not to push into this array and move to next. Okay, so when we like stop, when we are not like pushing that value, when we see that it is a middle one. Okay, so we will start at the middle one. So let's see what we have to write for this one. What is the thinking for this one? So like we use like tortoise, like fast slow pointer for this and finding the middle element. Okay, so I'm thinking that for solving this thing is that first of all writing this code in Java. I'm trying to write this code into Java. So let's see. So I have to write all this code inside this thing. So I have to write this code inside this thing. So first of all, I have to like, if head is equal to null, in that case I have to, if head head if head is null, so in that case head is null, head dot next is equal to, if head dot next is equal to null, null. So in that case return null. So in that case we have to return the null value. Okay, so this is a case when we have only one element, and if next is no other element, in that case we simply return the one value. Okay, this is the edge case. And the second thing is that second so finding the middle element, we know that we use like two pointer, that is like slow and fast, like it is list node list node. Slow will be like slow at D, so this is the slow, we point at the head. Okay, and list node is fast is equal to fast is head dot next. Okay, so this is, and we run the while loop. So till we run this while loop 1 2, let me plug in this one. So run this while loop till slow is not is equal to null, and fast not null, and fast dot next is not null. Okay, so run this while loop till like past is not is equal to null, and past dot next is not is equal to null. Okay, so in that case we can write this code. So what we have, like, now we know that how to move our pointer. So in that case we simply slow is equal to slow dot next. Okay, and the past will be like past dot next dot next. Okay, so we reach to the position and we simply delete, like, slow dot next is equal to, like, we simply uh, point that thing. So we are reached to the middle node. In that case, slow dot next is equal to slow dot slow dot next is equal to, we move to the next pointer, to pointer. Slow dot next is equal to slow dot next dot next, and then return head. Okay, so this is the logic I have thinked, like, so what we have to do. So this is like this thing. Okay, so 1 2 3 4 and 5. So we know that 3 is middle, so like plus slow and fast. So this one is like slow, okay, and this one is a fast. We're starting from this one. Like, first of all, slow move 1 point. Okay, in that case slow move 1 pointer. In that case fast move to 2 points. So 1 2 2 jump. Again slow move to 1 point, but slow dot next is equal to, like, this one. So this will be the stopping point, so this will be the stopping point. Okay, so now we have to point slow dot next is equal to the slow dot next. Now we are reached to the middle point, so we are at this position. Okay, so we are at this position. So in that case, so okay, so in that case, first of all, we move to the next position, and then we have to, like I have to point slow dot next is equal to this thing. And slow dot next is equal to slow dot next to next. So we point to this position, we leave this position, and return head. So in that case, it will be written 3 4 5. Okay, so this is the exact value you expected from this our answer. One more thing, so when we just stop, okay, fast is null and this thing, so we move one step and it moved next step. So okay, to understand the logic, so we use this here and turquoise method, like slow pointer, slow and fast pointer method. So in that case, we reach to the middle node and we assign this slow dot next is equal to slow dot next to next. Okay, we assign this slow not next to next. Okay, now okay, okay, that's all. That's an easy question, and we finish in like 15 minutes. So you can practice from your side. Good night.